Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Hey Houston, we don't have any problems. Today we're going to solve one of the kind of weird types of problems. They're called relative motion problems. So let's do the kayak problem. So you got a kayak. Now, the kayak problem says that you're trying to get across a river, all right? And the river is 68 meters wide. The kayaker can kayak at a speed of 7.2 meters per second, all right? That's how strong he is. But he's in a river, right? And this river is flowing north to south at a speed of 4.8 meters per second. And the guy, if he's walking, he can walk at 2.3 meters per second. Now, hopefully you're realizing this, but if he starts kayaking straight across the river, he's not going to end up straight across the river. He's going to end up downstream. So the question is when he gets across the river, how much time does it take for him to get here? Well, that involves him paddling across the stream and then getting out and then walking up here at 2.3 meters per second. All right, so let's see if we can solve this problem. So let's think about this. How long does it take to get across the stream? Now, this right here, 7.2 meters per second, is his Vx, right? Vx, velocity in the x direction, is 7.2 meters per second. And since the x direction we know to be 68 meters, we actually know how long it's going to take him to get across the river. You might recall the equation V is d over t. We know V. V is 7.2 equals d, that's 68, over t. We get our calculator out, we rearrange. I won't do too much math, hopefully you can follow along. 68, I'm going to divide it by 7.2. That's rearranging it, I'm doing it pretty fast in my head. That's going to take me 9.4 seconds. So 9.4 seconds for him to get to this spot downstream. But then what does he got to do? He's got to then walk up this far. Now he can travel at 2.3 meters per second. So next we got to figure out how far does he need to walk from here to here. So we need to know this distance from here to here. But we know that the stream is traveling at 4.8 meters per second. So if you will, that's like Vy. Vy is 4.8 meters per second, right? In the y direction. Technically, we might call it negative 4.8 meters per second. And we know that he's going to be traveling for 9.4 seconds. So how far much downstream did he go? Again, we're going to use our simple equation. V is d over t. And our v is 4.8. And our distance, we don't know. We do know our time, though. That's 9.4 seconds. So we're going to do our math. It's 4.8 times 9.4. And I have a mistake. We'll take 4.8 times 9.4, and that gives me 45 meters, meaning that he's going to be 45 meters downstream. Now, I want to figure out how much time to walk 45 meters back to the north, traveling at 2.3 meters per second. So we're going to use V equals d over t. Again, in this case, I know that that's 2.3. That's how fast I can walk, or a kayaker can walk. His distance is 45 meters, solving for time. So that would be, flip that, so 45 divided by 2.3. And that is going to be 19.t equals 19.6 seconds. So let's think about this. How much time is it going to take him? 9.4 to kayak, 19.6 to walk. So I add these two numbers up. 19.6 plus 9.4 gives me a total time, so T tot we'll call that, is equal to 28.9 seconds. But do you realize that there's another way for him to travel? What if he were to shoot off at an angle up? Then he could land here and have no walking. Let's solve that now. So let's diagram this. So the kayaker starts at this point and he shoots off at some angle, and we want him to land right here directly across. Now remember that what's happening is the river is flowing at 4.8 4.8 meters per second, and he can only paddle at 7.2 meters per second. So how fast will he travel in the Vx? Because this is 7.2 at an angle, 4.8 at an angle, so this is going to be a Pythagorean theorem problem. I can say, 7.2 squared, that hypotenuse, is equal to Vx squared, this is Vx, plus 4.8 squared. So if I want to solve for Vx, I'll take 7.2 squared, right? So I can say 7.2 squared minus 4.8 squared equals Vx squared. So 7.2 squared minus 4.8 squared equals, and I take the square root of that answer, and I get Vx to be 5.4 meters per second. So he will be traveling in the x direction for 5.4 meters per second. To find the time, V is d over t. And what's V? 5.4 equals d, 68 meters, divided by time. And you do the math here, and time will be equal to 68 divided by, not 5 point, this is 5.4, divided by 5.4, and this will take him about 12.6 seconds. So notice 28.9 kayak and walk, 12.6 just kayak. So the difference, if we're trying to find how much time will he save, it's the difference, right? So I take 28.9 minus 12.6 time saved. So delta t, if you will, is 16.3 seconds. So that's a relative motion type problem that you might see. Next video, we're going to do another relative motion problem. We'll see you in class.
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.